So hello everyone, welcome to OneClass YouTube channel. My name is Devansh and today we are going to go through a couple of popular physics question and answers. So these Q&A are going to be at university or high school level, and a little bit of background on myself. So I'm in the final year of my graduation and in my graduate is engineering. And if you need any homework help or if you need any tutoring help, if you want to online, then you can check the links in the description below. So without wasting time, let's just begin with our lesson. So which we see, yeah, this is question number one. It states that a flywheel is initially rotating at 20 radians per second and has a constant angular acceleration. The 9 seconds it has rotated through for 450 radians. Its angular acceleration is, then we have multiple choices. We'll just write the initial rotation. Let's write the rotation will, so let's write it red. Then after 9 seconds equal, we have stated the, it will be theta. Rotation will be 3 radian. So in such kind of problems, we have the formula as, I just go with the answer given by Junior. So we are going to use the concept of rotational mechanics that we have that equal to omega times c plus linear translational mechanics. We have 80 plus or t plus half 80 square, where it will be half t square, where omega naught is known, t is, we are going to calculate because it is going to be the angular acceleration, and theta also we know. We'll just substitute the values. Half alpha in square, this will be 40 minus 20 into 9 will be 1 t half. Multiply and divide to it. This will still will be 2 over 81 to 50 minus 1. So I will just use my calculator for this. So this will be divided by 2 we have 6.6666. This will be say as 666, let's say, radian per second square. Now in the options we can see that the unit of acceleration is not correct, but it can be the printing mistake from the questionnaire side. So here we can see we have the option D here, which is 6.7. The 6.66 we can round it to 6. Therefore the answer is D. The answer provided by the tutor is the same one. Therefore the angular acceleration, or I don't know what is this ID, of the flywheel is 6.7 radian per second square. Therefore option D is the correct one provided. To admit that you are not sure about the units mentioned in the choices of the question. Okay. So the solution is correct. Good work. Then we move for question number 2. Is going to be question number 2. So for the following figure, there is a coefficient of kinetic friction. This question, there are not a lot of spaces. So I'll just read this. So for the following figure, there is a coefficient of friction. Let's say mu as the coefficient of friction 0.20 between the blocks and the ink. Find the following. We have also given points for this question. So nice. The constant force F required to keep the blocks moving up the incline with a constant velocity, assume they were already moving, and B is the constant force between the two blocks. So I will just draw this diagram. We have the degree, we have a box, we have a, this is 3 kilo, this one is 2 kilograms force, this F, this direction, and obviously the block will be moving in direction. So here we are just going to resolve these vectors. So let's say this whole system, a mass of, let's say, capital N. So capital N will be kilos. It is the combined mass of these two blocks. Then there will be weight acting in downward direction. This will be E. Then we can take the components of force. This will be equal to E. This will be normal. So this angle is going to be 30 degree, because this one is 30. Then we have this triangle, and when we complete this triangle, We use some basic trigonometric or mathematical geometrical identities. Just find out, and this angle will be 30 degree. Then this will be cos 30 degree, and this component will be 30 degree. Now we can see that. So let's just draw the force diagram. So this was capital M, this was normal force, which is E cos 30. This is the force in the direction, E 30 force which is in the opposite direction of this parallel. Then if the block is moving in downward direction, then there will be friction in the opposite direction. Friction force will be this direction, in the direction of capital F. And friction force, normal force, coefficient of friction. So we'll just write the equation for my F plus small f equal to d sine 30 degree will be 3 degree. Small f is cosine 30 degree times. Now I can say that take the common. So this M is going to be the capital M, mass of whole combined. This sine 3 minus 0.2 times 30. So we can always use a calculator for this. This will be 3 minus 0.2 into cosine 3, 0.3267. So this will become the total mass is 5 kilos, 5 into acceleration due to gravity to 0.326. So I'll do the multiplication here. We have 16.01295, and this was 4, so this will be Newton. So let's just check the answer. They have given 32.98. I'm not sure. I'll just cross check this. They had just 0.22. This was cosine 3. Okay, was minus. I did mistake. This will be this be this was minus 0.5. 0.2 into cosine of 30. This will be 0.32. Then multiplied by 5 and then 9 point. Hope I was correct previously. 0.125. Okay, now I see. So they have basically added the full friction force. They thought that, let me just read the question between the constant force F required to keep the assumed they were already moving. Force F required to keep the blocks moving up the incline, the constant velocity. They will move the incline to keep the blocks moving up the incline with a constant velocity. Okay, so this is a pretty much force required to keep the block moving line. Okay, so basically this question uh, this question is pretty much, it is a different kind of question because these blocks are upward direction due to this force. If they are moving in upward direction, then friction will always be in the, so friction is this, therefore will be minus, will be minus, or then it will, and hence will be 0.673 multiplied by 9, and now it will be 32 point. So this here you can also see, and I can also see that each and every word in the problem of physics problem is very much important because each and every word can change the problem. So initially I was assuming that we need to find the force to keep this block at zero velocity or at stationary, but later on I found out that the blocks are moving in upward direction and we need to find the force to keep this block moving in upward direction, and that will be with constant velocity. So this was the A part. Now we'll go for B part, the constant force between two blocks. So the force between two blocks, the same as the force need to keep the block 3 kg moving up the incline with constant velocity. So the force between two blocks will be, the force between two blocks will be the same as the force need to keep block 3 kg moving up incline with constant velocity. So in this case, for B part, we need to find the force, this 3 kg block. So we just need to find the F, this 3 kg block, and we are going to use the same equation. So in this equation, instead of putting capital M as 5, we will put capital M as 3. So it will be 3. This sign and these terms will be same. F will be same. So sin 3 and cosine 30 will be same. So till here it will be same. So 5 will be putting 3. This will be divided by 319.7922 newtons. 19.79 newtons. So the solution given here is correct. Good work. So we'll go to question number 3. So two sleds are hooked together in the it is ton mass shown in the figure. The front sled is twice as massive as the rear sled. So the mass of front one is 2 times the mass of second one. These sleds are pulled along a frictionless surface by an applied force. We have no friction. Then we have, let me draw a block diagram. Rho m force and then the tension in the rope between these sleds. So is T determine the ratio of the magnitudes of the two forces T by F. So let's just assume that this whole system is moving in forward direction. A, the acceleration, then my total force F will be mass into acceleration, and in this case mass is going to be total mass, which will be mass of first block and second block times acceleration with 3a. Now this is the force. We need to find tension. So tension is going to be the force which is pulling this small block with the same acceleration a. So it is going to be the mass of small block, which is m, and the acceleration, because whole system is moving with same acceleration, so this small block will also with the same acceleration. So T is m into a. We need to find P over S will be m a over 3 and a. This can get cancelled and it will be 1 over 3. So T is to S is 1 is to 3. So here also T is F over 3. So correct. X solution. Third one. This is going to be question number 4. So a spring scale is fastened to the ceiling of a railway car. When a 1 kg block is hung from the scale, it reads 12 Newton and is oriented as shown in the figure. What is the approximate acceleration of the car as measured by an observer at rest on the ground outside the car? So it is necessary for the observer to be outside the car or a different frame of reference so that he can observe the acceleration of the car. And for this figure, we can easily draw the diagram. So let's say this is the ceiling of the car. Use this. This was the spring balance. Spring balance, we had a mass. This is 1 kg, and let's say we have this balance here. It is reading 12. Now we have a 10. Basically tension. Now I'll take two components. So this is my vertical. Let's say this is the angle theta. Now for this I'm going to have two components. One will be in this for this mass. This will be in vertical direction, and for tension we are going to have two components. One will be in this direction. This will be T theta. This will be theta, and my force is this direction, so it will be, which is, now I can just resolve these vectors. So what we need to find is we need to find the acceleration, and write A is equal to T theta, but we don't know this theta, so I'll use this vertical one first. So T cosine theta is T. I know the value of T. 12 cosine theta is mass is 29. This acceleration of theta will be cosine 9.8 over 12. Then we take cosine first. Theta is 5.24 degrees. Now I'll put this value of theta in this equation. So my mass is 1, A is acceleration to 12 of this is 35.24 degree. So will be 12 into sine of 35.24.577. This will be, A is coming out to be 6.2 per second square. I'll just cross check this. So this was P cos theta, P sin theta equal to M equal to theta. We have P cos equal to M cos theta 8. Well, we put the angle. Let's check the solution given by Janine The Tutor. So here it is 6.925. So pretty much same answer. So again, we can say solution given here is correct. Good work. We have question number, in question number 5 they have already given the answer. Wow, like this. So Samson swings the 1200 Newton weight about a vertical axis in horizontal circle. The length of the attached rope is 1.2 meter. What is the resultant force acting on the weight? Okay, we need to find the resultant force acting on the weight. So basically we need to find the sign, the centripetal force. So I'll just try to draw this diagram. This is the vertical, this is the rope, the body box. This box is of 1200 weight. This weight is 1200 Newton and this angle is given as 40 degree. Okay, so in this solution, in this question, we can clearly see that this rope is of the 1.5 meter, which is already given, and this is going to be the tension force, and tension force will have two components. So if I draw a vertical here, then this angle will be 40 degree. These will be two components. So in vertical, horizontal, we have the theta. Here theta is 40 degree. So what I need to do is I will first calculate T. So T will be, T cos theta will be equal to weight. T will be resolve for vertical direction. T cos theta W. T 40 will be 12. P will be 1200 divided by cos 40, 1566.48. So we have T. Now we need to find the centripetal force. The centripetal force is going to be this one. The T sine theta is going to be the centripetal force. Will be T sine. So T is 166.48 Newton to sine is 006 point. This is centripetal force and this is again T sine theta. What is the resultant force acting on the weight? So this is going to be the resultant force, which is, so they have also rounded this as 007. Again, correct solution. So this is going to be question number 6. So we have a diagram here. When the system was released, the system accelerated at 2 meters per second square. Calculate the net force acting on the system. When the system was released, oh, it is again repeating. So transcript image text. When the system was released, again it is repeating the question. First, I will draw this. Physics, it is very necessary and it is required to draw the diagram, especially in the problems dealing with mechanics, because it gives a correct idea to solve it. Really, this small square here, draw the box. Erase the extra part. This now this looks. I'll write the mass 6 kgs. This is 4 kilos, and this whole system is accelerated. So it is 2 meter square Now for this, we do not have any friction coefficient, so we'll assume this as frictionless. Then we need to form the equations. So this whole system is moving with a acceleration. So here there will be an acceleration a. Here there will be an acceleration a. Then talking in terms of forces, this will be m. So this will be the tension. This is going to be n, and in this direction, this let's say this as capital N. This will be A, because this is moving. This 6 kg block is moving this direction. So the tension is pulling it, and will be equal to, okay, yeah, here we have this. So and then, so first I will write the equation for this 6 kg block. Will be E equal to capital. Then the equation for this one, the force is acting downwards, so I will say this will be force, the acceleration it will be in downward direction, EMA. This will be to T. So here also they have T minus 2G equal to M2A. So this is second one, T minus M2G equal to M2A. And for first one we have F equal to M1A plus T equal to F minus T equal to M1A. If I see for this first block, we'll have F minus T, so F plus A going to be equal to 1A will be in the same direction T, so M1A plus T equal to F in this direction. T equal to, I'm not sure for this first one. We need to calculate the net force, right? So the net force will be, first I'll just calculate tension using this second equation. This is 4 into 2 plus 8, 4 to 9.8. This is 47 to, this is tension force, Well, due of tension, so this whole system is and the system is the acceleration of A. So 10 times. I'll just look at the other equation. I think I'm back. Yeah. So yeah, I figured out what was happening here. So I was missing one force, the F1. So in the first equation, this M1A is the basically this direction. This will be capital M into A. And then we have an overall force for this system, and this will act the same direction as the acceleration. This will be F cube or F vector. Then we are going to just correct this equation. So, yeah, and this F is given as, or this T is given as, so we have the magnitude of T. So what we'll do, we just need the acceleration, the acceleration. We'll use first equation. This will be P minus A, or basically this will be negative, I think. This force was in negative direction. So I'll just write F equal to T minus A, or equal to T plus A basically. Then F is T was 42 Newton plus A 6.2. This will be 47.2 plus 12, 59. So 59.2. Here we have the solution. Correct.